Okay, one of the things we need to do, guys, in Ireland is insulate our attics very well. And we're going to show you a little clip on that now in a few moments. But before you do that, you got to make sure, you got to see if there's any penetrations in the ceiling of your house, which could lead to air leakage and heat loss and vapor movement up into the attic, none of which we want, okay? And this is a classic thing, isn't it? You've got your recessed light here. You could also have pipes coming up from downstairs, which are carrying water, electrical cables or whatever, and these are all penetrations in the ceiling of your house, which we want to seal up. So now the thing about these recessed lights is they generate heat. So it's not a good idea just to place insulation directly above them. You should definitely not do that. And in actual fact, what people end up doing then is because they leave insulation away from this, you end up with holes in your insulation all over your attic, which is kind of not a good idea either. Okay, so we want to put insulation over it, but we don't want to put insulation directly in contact with it, and we also want to make it airtight. So there's quite a few things to do here, but thankfully there's lots of products that are available on the market now. One of them being this hood, if you like. Sometimes people call it a top hat, and essentially what you do is you place this over your recessed downlighter like that, and it gives about 70 millimeters of free air, if you like, between the top of the light and this here. So if you could put that in place now, and then you can insulate your attic, everything would be fine, wouldn't it? However, this isn't airtight. Obviously you're going to have drafts leaking up through that. So let's think for a second, how would we make that airtight? And the best thing to do there would be to use some airtight tape. Again, don't use duct tape, because duct tape won't last very long and it'll eventually delaminate and fail, and it will have undone all the great work that you invested in. So I've got a roll of airtight tape here. We've seen this product, these kind of products are widely available nowadays. And what I've done is I've cut some strips of this tape now, which I'll apply, and just to demonstrate that to you. So we peel off the backing paper like this and expose the sticky side like that, and then we very carefully apply that to all four sides like so. And I do that around all four sides, as I mentioned, to give a completely airtight seal. Now, when you're putting on this airtight tape, it's a great idea. It's recommended to use what they call an applicator card. If you just rub it with your hand, you won't get the same level of adhesion. So we like to use these applicator cards. I'll just show you that here now. So we put our tape down like this. We remove the backing paper and we put it in place with this applicator card. The adhesives for these tapes are what they call pressure activated, and so the more pressure you apply, the greater the bond that you'll get. All right, so we can see now that that's really nicely stuck down. It's super airtight, and now we can go on to the next phase, which is putting insulation in our attic. Now that we've sealed up all the service penetrations and we've got our attic hatch sealed presumably as well, the next thing we want to do is insulate our attic. We've got insulation in plastic bags here because when you come to the training centre to do this hands-on training, we want people to be able to work in their normal clothes without having to suit up. So insulation doesn't normally come in these bags, but it's just for simulation purposes. So we put in our insulation. This one here is above our recessed light. We put that there. I've got some more insulation for this part of the roof. We pop that in here and we put that insulation in there as well. Now, so you're looking at that now, you're thinking, God, that's great, I've done my insulation now, but you still have a pretty significant thermal bridge in your roof. I don't know if you can see that or not, right? So we filled between the joists here with insulation, but the joists themselves are quite a significant thermal bridge. And how do we get rid of that? Well, that's actually very simple. We just put a second layer of insulation at 90 degrees to this first layer. And so that insulation goes directly above the joists and eliminates the thermal bridge. I'll show you how that happens now. It's very simple. So we just take another layer of insulation there. And now you can see that for the majority of the roof now, we've negated the thermal bridge of that situation there. Okay, now, where are we doing now? So we've insulated our roof. But can you see here now that the insulation actually, we can bring the insulation out perhaps a little bit, but we do have a thermal bridge effect here that I want to talk about next, because that's a real problem in Ireland. We have a lot of mould in houses in Ireland, and the reason for that is because there's a thermal bridge often at the eaves of the house. In other words, where the roof insulation meets the wall insulation. So let's investigate that a little bit further now and see how we might solve that. So what we're going to do in this experiment here is we're going to externally insulate the house, all right? We know that external insulation is a very good solution if you're trying to do a deep retrofit on your home. So let's have a look at that now. Now bear in mind, guys, that it's very important to have your attic ventilated. It's very important that fresh air can get up above the insulation to ventilate the attic so that you don't have a build-up of humidity. So we have to keep that in mind when we're doing all of these things. And you'll see now I've addressed that in the way we've cut the insulation. So I've got some insulation here. You'll notice it has a chamfered angle here at the top. You might be curious about that. You notice it also has a cutout. You might be thinking, oh God, I wonder what that's for. So I'm going to show you now. We've pre-cut this insulation so it makes the snuggest possible impact at this eaves location. So let me install that now. So I can install that here. Okay, and then obviously I would be insulating the rest of the building. So I'd have another piece of insulation here. All right. Then I would continue along, of course, all along the eaves. This goes up here, and that insulation would go there. We make sure that we put the insulation in a brick pattern. So because we've got a joint here, we don't want to have a joint to this location. We have a joint here, and you can see it's not aligning with a joint there. So we have a brick arrangement there. So that's all great. That'll reduce the heat loss through the wall, okay? And you have to have a 50 millimeter gap here, a continuous gap along the eaves. Your soffit would go here, and there'd be a ventilation tray down here, so the fresh air can come in, can come up here, can go over the top of this insulation and into your attic, okay? So everything seems fine there, doesn't it? We've now insulated the attic and we've insulated the wall. But there's still a major problem here, okay? This insulation in the attic is not in contact with this insulation here in the wall. And that's going to represent a thermal bridge, which would eventually most likely lead to mold on the house interior. So we've one more challenge to overcome in this little journey here, and we've come across a product that we're very excited by and we think could be a real game changer in eliminating thermal bridges along the eaves. So I'm going to show you that in the next step. This is the wall that we've externally insulated it. It's a cavity wall construction. It so happens that it was partially filled with insulation when it was originally being built. Now, you would never ever do external insulation if there's a gap in your cavity wall. In other words, if there's insulation missing here. So we've actually pumped the remaining cavity here with blow-in bead. So we have the existing insulation, we have the blow-in bead that was put in there, and now we have the new layer of external insulation. So we've got quite a lot of insulation in the wall there, haven't we? Which is great. And our insulation comes up here, doesn't it? So it doesn't stop here, it actually comes up to about here. And then we have our roof insulation. But as I mentioned earlier on, This roof insulation now, ideally, or not ideally, but really needs to connect with this external wall insulation. But we also have to maintain this 50 mm ventilation gap here. So it's almost like we need something which is super thin, which has really, really good insulation value, and which is stiff enough that we can shove it, we can insert it from the inside. Because remember, when you're insulating a house, this is going to be covered with tiles and battens and so forth. We've come across this great product called Aerogel, and Aerogel is not very familiar to most of us, but it's got an incredibly low conductivity value. It comes in something that feels and behaves like sort of carpet underlay. It's quite stiff, but also flexible, if that's not a contradiction in terms. And because of its kind of stiffness, you can imagine we can insert it actually quite easily from the inside of the attic, shove it out here to make the connection between the attic insulation and the wall insulation. But it's thin enough in section, you can see here, probably 15 mm or something like that, that it won't interrupt our ventilation gap, which is very, very important. So we're very excited about this product, and you can insert it quite simply like this. That can be inserted there like that. We can pin this down with some plastic pins and put some insulation above that there, and still have our ventilation gap here. So we believe this is going to be a game changer in terms of mold remediation when we're dealing with deep retrofits in Ireland. So it's connecting again the external wall insulation with the roof insulation. It's called Aerogel, and it's a product that we think could have an enormous application in this type of scenario.